Super. Welcome back, everyone. For me, it's the same night. I'm not wearing the same clothes day in and day out. For you, it might be a week since we saw each other last. Today, we're going to talk about the digital electronics. Last time, we were talking about basic electronic theory and the components that we use. Today, we're going to go into the digital universe and move into how we start working with Arduinos, covering a little bit of the smallest baby steps of getting the IDE to work. So, just like last time, this is a part of a European project, Discover Robotics via STEM, sponsored by Erasmus, and we hope to help students and teachers around Europe to become more familiar with Arduino, so we can use it in teaching the next generation so they can become even better than we are already. And we are from FabLab Nordvest in Copenhagen. So this is the introduction to digital electronics. I assume that many of you who are here really want to start working with this. This is a Arduino Uno board, or at least designed by Arduino. It is one of many platforms from which we can create simple prototypes. There could be other platforms like Raspberry Pi or the Spike Prime from Lego. Maybe you've worked with Lego Mindstorm. But in this relation, they are very expensive platforms. And this is why this small little board is by far the most popular prototyping platform in the world when it comes to mechatronic or robotic prototyping. It is super great, and I do understand why a lot of you want to learn how to use these. Just to take a little bit back to the beginning, just like we did last time, when we talk digital electronics, what are we actually talking about? Look at these two curves. One of them is a digital signal, the other one is an analog signal. When we talk analog, we talk a wave where we can allow values between everything, in this specific example, between 0 and 5 volts, down to -5 volts. And all values between 5 and -5 are allowed to be recognized by the system. In digital, we deal with either a high or low situation. With 5 volts or 0 volts, quite often represented by either a 1 or 0. So in this regard, we kind of start controlling electronics, or the whole digital electronic universe is, you can say, surrounded by this idea of having a absolute value and a nothing value. From Wikipedia, we have this definition about the field of digital electronics. I think most importantly here is that we, again, understand what a digital signal is and how we can then later translate into what it is that we're actually seeing. Because what kind of came from the digital electronics field is that we started being able to utilize simple coding, things like Morsing, to actually get the computers to work in certain ways. And we did that using small simple circuits called logic gates. This is just 3 examples, the NOT and OR gate, which are also terms that you are very likely to hear when coding. That is not a random connection. That is because we built the entire functionality of coding on top of the idea of having ones or zeros. Today, however, we have become extremely good. This is just to visualize it, a more specific example with some components of how these work, if you want to kind of get into these different digital gates from before. But it is about these types of microprocessors. So let's jump into the Arduino in front of me here. The Arduino has a lot of different functionality. These are the digital pins. They either read or write, which means either they expect to be able to see a value from something else, or they send out a value themselves in a digital system with a small, you can say, secret that we can talk about later, which is the ability to kind of mimic analog signals which is symbolized by this small wave, which is called tilde. The, you can say, core of the Arduino is this thing. That is the microprocessor. What is really important here, special about this, is we have created an extremely small circuit where we have the ability to create the logic represented in the gates from before. And what is, you can say, new compared to these simple small circuits is that we can change the behavior from the computer, which has kind of dramatically changed how we approach coding and prototyping today. And what Arduino has done, which has been always, you can say, was extremely unique for that time, was to make it in such a way that everyone could get access to it because they were cheap, and also the coding was super easy. I have met a lot of engineers in my life who have done robotics engineering or electronics engineering in a much more simple way, where it's much, much harder to get started. For me, as a design engineer, I have been able to pick this up within 6 months of just working with it. And I believe that even though some of you might be young, most of you should be able to do that too, if you so wish. It is really, really quite easy to get started with Arduino, but it does help when you do understand the basics of it. So we talked about the digital pins, digital signals. The Arduino also has the ability to read analog values. That is symbolized by the A pins here. And then it has a couple of, you can say, fundamental functionalities like having a ground or having a 5 voltage source on it. I want to just talk briefly about programming languages. As I said, many years ago, what we were working with was ones and zeros, just like the digital electronics field is kind of came from. Now we have advanced languages that allows us to change the functionality of these microprocessors to meet our needs. And the Arduino language is kind of in a weird spot because it's very closely related to C++ or C#. I think also there's some elements from that. But it does have some simplicity to it. So I would say it is somewhere in between programming raw C, which is a language that you can talk to computers, and Python, which is also a other very, very popular language. But again, someone before us, many engineers and scientists of the past, have allowed us to be where we are today by creating all these languages, by creating all these circuits for us. So just send some good energy to the people who did that because it has made everything so much easier, and we've come much closer to be able to almost just speak to the computer, and then we can get it to do what we want, which is, since the last year, I'd say almost actually become a reality. But we're going to dive into that next time when we start talking more about coding. So again, what is really special with the Arduino? It is this communication of being able to take a idea from your and then you write it down in your computer, and then you upload it to the Arduino, and it will actually follow these directions or these recipes. They are also, in this context, often called algorithms, or you can or even just software or whatever. It's not really important what you call it. It's just really important to understand that we kind of give this idea, turn it into a coding script, and then upload it onto the Arduino, and then right there we now have a small microprocessor executing the commands that we taught it to do. What I want to do for the last 20 minutes here is basically to go into the Arduino IDE, which is the development environment or integrated development environment, because I would say probably 50% of the people who would like to work with Arduino, they stop right here. They stop because nothing works, they don't understand the functionality of the software, and they don't know how to even get started with the simplest things. So what we're going to do now is we're going to dive into the Arduino IDE, and then we're going to jump from that into Tinkercad, which is an online software where we can program virtual Arduinos. So even though you don't have one at home, we can keep moving with this anyway and learn about how to program the Arduino. Very good. Welcome back. This is the just small video addition to the video about digital electronics. What I'm going to cover here is how to start being able to just simply start working with Arduino, how to download the IDE, where to do it, and how it looks when we then open it. I do have several generations of it, so we can look at those as well. First of all, I would just go into Google, Arduino IDE, the Arduino website itself. Just press IDE 2, it should be out now and ready. We press download, we go to this page right here. Windows, Linux, Mac OS, it has all the compatibilities. That being said, in my experience so far, it seems to be working better on Windows. I have no experience programming it from Linux. But I have assisted teaching university courses on programming with Arduino, and we had quite a lot of issues with people who were working on Macs being able to connect to the Arduino. However, that being said, it should for most of the time just work just fine. But Windows, in my opinion, or in my experience, just a little bit better. Let's press this. Arduino is open source, or is at least very much mostly open source. You can decide whether or not you want to do this. I'm gonna do this option for now. Just download. We open it here. Boom. A quick installation. Just for me. Yes, yes, yes. And as this is going on, I can just kind of jump into one of the older IDEs, and then we can look at the differences in a second. So let's just jump into it. This is how the Arduino IDE 1, at least this is 1.8, looks. This is just a huge interface for coding. This here is the verify, which is kind of checking whether your code is uploadable. This is the upload system. Then we have files, edit. I'm sorry this is in Danish, but I hope you will be able to work with it anyway. Something about sketches, tools. Tools here is quite important. That's where we choose the boards. And the ports, which we hopefully will be able to see in a second, is also where you do manage libraries, which is extremely central to Arduino coding. Just finishing this up, then you can see the differences and why I would actually, for the most of the newcomers, actually recommend this new IDE. So let's take a look at it. Yes. Very good. One of the things I really like about the let's do this later. I like about this new one. Oh, it's fine. Yes. Yes. Okay, installing different boards here, I see. That will likely happen to you as well. All the different drivers. But what I really like about this is we have files, we have libraries here, which makes it much more easy to access this part of the Arduino functionality, which is all about these huge libraries of codes that other people have made for for your different setups. So I just wanted to kind of jump into the second one here to show you the differences, how it looks when you install it. At least I do believe that that is the better version. So this is what the standard setup looks like for the Arduino code. There's the setup, there's the loop. We're going to dive into more of the principles of coding in a second, but there are still a couple of things that I would like to show you. So I can see this one is in English as well. So we have the file here, sketchbooks, examples. I think examples are super usable, super great for you guys, and very usable. And we are going to, in later sessions, pop some of these codes into the Tinkercad version as well to see how it looks, but just understand that these are there. Again, we can still access from tools, we can access the managed library parts, but it is the same that is there is here. And then we have the different boards manager. This is also extremely great if you practice Arduino for some time and you kind of want to make the jump, maybe something where you can do more of a Wi-Fi connection, stuff like this. There are certain boards that you would then need to download, but for now we're going to stick to the Arduino boards. I'm going to try and just connect a Arduino real quick. I just need to get myself an Arduino wire. Very good. I'm going to plug it into an Arduino and hopefully we'll be able to see it in a second. Very good. So what I was hoping to see here, and that is the board manager here as well. So hopefully I was looking to choose the Arduino Uno. Then we go to port, and then we can see here COM for Arduino Uno. So let's try and just quickly see how it looks if I then, for example, mess up a code or I've done something to a code. We can just say the blink without delay here. It opens a new window. Let's see if I, for example, do this. It has a code that turns on and off an LED on the Arduino. So maybe I'll just remove this comma. See what will happen then. Then I try to press the verify option here. And it says, there's an issue. And then rolling through, you can see that this line is not working. Oh, that was a comma. So again, we press verify. Now let's run through it. It says everything's fine. It uses very little space on the Arduino and we can definitely upload it. So that is then the upload option. We can also here see that it's trying to upload to the Arduino Uno. So that is how it looks when you have connected an Arduino to it. It's cool. Good, and here we have uploaded it. And I can say that the Arduino is blinking as it's supposed to do, and that again we're going to look into how these codes kind of function and work. But I hope that this helped a little bit. One of the most common issues I've seen helping people with Arduino is not being able to connect, and normally comes down to one of two things, actually kind of three. First one, the wire is broken. Quite often you get these Arduino wires and they're kind of a low quality. Don't worry too much about that, but it does happen that they kind of break and they don't work anymore. So buy more Arduinos. You only need to have one wire, and in theory you can kind of just go about them, and then some of them will eventually break, but I would say you definitely just end up having a lot of leftovers. Second is the lack of drivers. You did see that my computer installed all these drivers for the different boards in the beginning. If that doesn't happen, you might need to do that manually. but that is also another reason. And then third, just restart your computer. Sometimes that's what is needed, even though it sounds kind of dumb. And then again, before I turn off the screen recording here, I would just recommend by getting the second one. One of the differences is, for example, in this with being able to see what code is not going to work. This one does seem to be a little smoother in the interface, so definitely recommending that one for people who are looking to learn. But yeah, keep on grinding, guys. I'm going to check out for now. I'll see you all in the next video.